Hello, let's begin one more lecture session on multivariate calculus integration. Now we may remember that since last three sessions we had been talking about how to evaluate double integrals. And we have seen that essentially double integrals are evaluated by repeated single integrals. That means either we can first integrate with respect to x and then with respect to y, or vice versa. Now, today's lecture we will see how to evaluate double integrals using the idea of change of order of integration. So what does it mean? As the name suggests, it means that we will reverse the order of integration. That means in a problem, if you are asked first to integrate with respect to x and then with y, we will do it in the reverse way. We will first integrate with respect to y and then with respect to x, or vice versa. Now, why is it so? Do we really need to do it? Can it help us in any way? Let us see that with the help of a problem. So we have a question like this now. Evaluate the integral I 0 to pi by 2 x to pi by 2 sine y by y dy dx by changing the order of integration. Okay, so that means our inner integral which we evaluate first is with respect to y, and then we should integrate with respect to x. Now my first question is, it's already given, use the change of order of integration. Can we do it without changing the order of integration? Let us see it first. And in fact, at a glance, it looks like an easy problem because like other problems we have seen in the previous lectures, it seems we do not need to draw any figure and find the limits of x and y. The limits and x and y are already given to you. So let us give a try. Can we start it like this? So if we have to start, we have to first evaluate the inner integral x to pi by 2 sine y by y dy. Can you do it really? Give a try. Perhaps you won't be able to do it. You won't be able to integrate this function sine y by y because of this divided by y with respect to y. So actually, we won't be able to proceed with this integral at all if we first want to integrate with respect to y. So that is why it's a necessity in this case that we will try to change the order of integration, and we will see that whether it can help us or not. Okay, so changing the order of integration means first we will integrate with respect to x and then with respect to y, right? But that changing doesn't mean that simply we will reverse this x and y and reverse the limits of x and y also. For this, we really now need to draw the figure properly and then find out the proper limits as we will reverse the order of integration. So, as you see here, in your inner integral, y is varying from x to pi by 2. So that means we have here as one of the boundary, actually the lower boundary for y as y equal to x, and the upper boundary is your y equal to pi by 2. This is a straight line parallel to the x-axis. And x is varying from 0, that means the y-axis, to x equal to pi by 2. So this is actually the line x equal to pi by 2. So we have this cutting point over here. So this is our given region of integration. And see that in the given case, as we have to integrate y first in the inner integral, so therefore actually we had been treating this as a type 1 region and varying y from the lower curve y equal to x to y equal to pi by 2. Now, if we need to change the order of integration, that means now we will integrate first with respect to x. That means we will Now vary x fast from the left curve. What is the left curve? The left curve is your y-axis, that means x equal to 0, to the right curve, that means x equal to y. So as we reverse the order of integration, our new limits are x will vary from 0 to y and y will vary from the lowest value of y, that means it's the x-axis, y equal to 0, to y equal to pi by 2. So now we observe that under this reversal of the order of integration, we have changed the integral in this form. So now we are going to integrate first with respect to x. In the given integral, it was first with respect to y. Now we have reversed. So we will now integrate first with respect to x, where x will vary from 0 to y, and then with respect to y, where y will vary from 0 to pi by 2. And now let us see how this change of the order of integration helps us. We will see actually it really helps us. Why? Because we are going to first integrate with respect to x. So sine y by y, the function of y, this will be treated as a constant. So this actually helps. So because it's a constant, in fact, I can take it out, and now we just integrate with respect to x. So integral dx will just give you a x. Put your limit 0 to y. So that means it gives you just a y. So the y and this y in the denominator cancels out. So you just get sine y dy. And so as you integrate minus cos y, put the limits, your answer is 1. So I hope it's clear that how it was really helpful that we changed the order of integration, right? We were actually unable to evaluate the integral in the way it was given. But just by changing the order of integration, we have simplified our function. This y got eliminated, and so we could integrate it easily and got the answer for our integral. Okay, so let us see one more example. So now evaluate the integral by first reversing the order of integration. So what is that? X varies from 0 to 3, y varies from x squared to 9, x cube, e to the power y cube, dy dx. Now here again, as it is given, we are first supposed to integrate with respect to y and then with respect to x. Now if you try this, you can give a try, but actually a very similar situation is going to happen as the previous example. You will not be able to integrate because x cube, this will be treated as a constant at the moment when we will integrate with y. So we will just have e to the power y cube as the integrand, and it is not possible to integrate this function. So it will be actually necessary to reverse the order of integration in order to get an answer for this integral. Okay, so then as before, what we will do, we will of course first draw the figure which will just depict the region, and then we will do the reversal of the order of integration. So see that y varies from x squared to 9. So y equal to x squared is the part of the parabola, and y equal to 9 is here. Of course, a line parallel to your x-axis. And then x varies from 0, that means the y-axis, to x equal to 3. So this is the region which has been mentioned over here by these limits. Now see, once again, the way it was given, we were actually supposed to integrate first with respect to y and then with respect to x. But now we will change the order of integration, means first we will integrate with respect to x. That means first we need to change x. So what are the limits? X varies from, of course, this is your x equal to 0 to this curve the parabola. So x is of course root y. And now y varies from, the minimum point is here 0 to y equal to 9. So therefore, the given integral over here gets converted like this: y equal to 0 to y equal to 9 and x equal to 0 to x equal to root y, x cube e to the power y cube dx dy. And let us try to evaluate this integral now. Can we do that? Yes. So what is happening here now? We will first integrate with respect to x. So therefore, the function of y, we have taken it out and we just integrate x cube with respect to x. So that gives us x4 by 4. Your limits are 0 to root y. So as you put the limits for this function as 0 to root y, the lower limit of course gets 0, and in the upper limit the function now becomes e to the power y cube y square, and the 1 by 4 is taken out over here, and y now varies from 0 to 9. So can we integrate this? Yes, now we can integrate this. Mind it, earlier we were not able to integrate just this function e to the power y cube dy. But now we will be able to integrate this due to this y square term. How do we do it? I hope everybody remembers. It's a simple substitution you need. So we will substitute y cube equal to z. So that means actually that will give us 3y square dy equal to dz. That means y square dy will be replaced by dz by 3. And this e to the power y cube becomes e to the power z. So you integrate, put your limits, and your answer is now 1 by 12 e to the power 729 minus 1. So in both the examples, we have seen what? That many a times when we are stuck up with single variable integration, changing the order of integration can help us to get the value of our required integral. Okay, so with this we will close today's session. In the next lecture session, we will take up how to evaluate double integrals using change of variables. Okay, so thank you and goodbye till then.